Mayya here, and today we will practice Le Chatelier's principle, which is one of the major topics in general chemistry. So here we have an equation which looks like a complicated equation. We also have delta H, change in enthalpy, and we have some questions. We will write what happens to the equilibrium with these changes, and we will also answer the second question, which is what happens to other substances when the equilibrium shifts. So the first question says we add more OH minus. And the first thing that we do is we will locate our substance. So OH minus is here. And what happens when we have more OH minus? And we will use my little Le Chatelier's principle cheat sheet. So if we increase the amount of a substance, we will shift to the opposite side away from that substance. So if we increase OH minus, it's on the left, the equilibrium shifts to the opposite side away from it. So the equilibrium will shift where? It will shift to the right. Now, when equilibrium shifts to the right, what does it mean? That means that the products should increase and the reactants should decrease. Again, I'm going to the right, right? So where my arrow is pointing, that's where substances will increase, and here where they will decrease. So with that in mind, let's answer the next question. What would happen to the amount of Cu2 plus? I am shifting to this side. So if I'm shifting to the right, what happens to Cu2 plus? It will decrease. And there are many different ways to ask Le Chatelier's principles. Some teachers will just ask you about where the equilibrium shifts, but some teachers will also ask about their substances, equilibrium constants, and so forth. So this is going to be a more thorough explanation. Next, they're asking about increasing the temperature. So how do we deal with temperature? What we need to do is we need to look at delta H, which is change in enthalpy. And if delta H is positive, we add heat to the reactant side, to the left side. So here it is positive. I'm just going to add heat. If my delta H is negative, that means the reaction is exothermic. It releases heat. And I would add heat to the product side. Positive is endothermic. I added heat to the reactant side. Negative is exothermic. Add heat to the product side. That's the first thing you need to do if you see that you're dealing with temperature. They might not give you a delta H. In the question, it might say endothermic or exothermic. So you can also add your heat that way. Now that I have added my heat to the proper side, I can treat it as one of the reactants in this case. So I will deal with it the same way we dealt with concentration. Increased temperature means I increase heat. So to get rid of heat, I will again shift to the opposite side. The opposite side would be to the right. And when I shift to the right, the next question is about equilibrium constant. So this is a really tricky question. What is equilibrium constant? Remember, when we write equilibrium constant, it's products over reactants to their coefficient. So equilibrium constant is products over reactants. And by the way, equilibrium constant will only change due to temperature, so other things will not affect it. But here there is a change in temperature, so equilibrium constant will be affected as well. Since equilibrium is shifting to the right, we are going to make more products, less reactants. Products are on top in the numerator. So what will happen to equilibrium constant? It will increase. It will go up because we're making more products. Next, add some Cu solid. So first of all, Cu solid is here, and there is something very important that you have to keep in mind. If you change the amount of solids or liquids, equilibrium does not change. So changing the amounts of solids or liquids in your equilibrium will not shift your equilibrium, and therefore amount of Cu2 plus will also have no change. That's a very important thing to know. Next, adding a catalyst. What happens when we add a catalyst? What's a catalyst? A catalyst is a substance that speeds up your reaction, but it does not change the equilibrium. So again, for equilibrium, we will say no change. If we add catalyst to the equation, no change in equilibrium. Since there is no change, nothing will change. OH will stay the same as well. Finally, it says increase pressure. What happens if we increase pressure? Let's go ahead and look at it. If we increase pressure, we shift to the side with less moles of gas. So what we're going to do here, and that's because gas, increasing pressure means you will have too much gas. So you need to shift to the side that has less gas. You need to relieve this pressure. So what I'm going to do is I'm going to identify where I have gas. As you can see, there is no gas. AQ stands for aqueous. Both of my substances on the left are aqueous, so there's no gas on the left. And there is 1 mole of gas on the right. We said that increasing pressure will shift equilibrium to the side with less moles of gas. Since my left has no gas and my right does have some gas, the equilibrium should shift to the left. So we will say left or reactant side. And if we shift this way to the left, what happens to my Cu2 plus? So let's find Cu2 plus. It's here. And what happens to Cu2 plus when I shift to the left? It will increase. It will increase. This is Mayya. Let me know if you found this video helpful.